All right, 8.4, properties of rhombuses, rectangles, and squares. So the first thing we need to do is make sure we understand the definition of each. So a rhombus is a parallelogram. So we could throw in there and write all these things down, like it has opposite sides parallel, it has opposite sides congruent, it has opposite angles congruent, it has consecutive angles supplementary, its diagonals bisect each other. Just because it's a parallelogram, we know all that. And it has 4 congruent sides. So the new thing on here is 4 congruent sides, okay? So your rhombus, okay, all your sides. Wow, that drawing is terrible. Let's see if I can do one more time a little better. Okay. There, that looks a little more like it. So I have 4 sides, and all 4 sides are exactly the same length. That's what makes it special to make it a rhombus and not just a parallelogram. So a rectangle, once again, is a parallelogram. So it has opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals bisect each other. But it also has 4 right angles. So what's special about a rectangle is the 4 right angles. Okay, that makes it different than the rhombus. Okay, so now I have the next one, which is a square. Once again, it's a parallelogram. It has opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, diagonals bisect each other. And it has both 4 right angles and 4 congruent sides. So I get 4 congruent sides, 4 congruent right angles. Okay, so just kind of a note here, a square is a rhombus, a square is a rectangle, right? Because it fits those definitions. Okay, so let's go through now and say what's new and what's different about a rectangle, a rhombus, and a square that we can say for properties. Okay, so as far as a rhombus, a quadrilateral is a rhombus if and only if it has 4 congruent sides. So this just goes with that definition up there. So if we have 4 congruent sides, it's a rhombus. A rectangle, a quadrilateral is a rectangle if and only if it has 4 right angles. Okay. And I do want to point out, do you notice in both of these the if and only if and only if. So we can flip it around, right? We could say if there's 4 right angles, then it's a rectangle. Or if it's a rectangle, then it has 4 right angles. You can flip those around from either direction. And then we have the square corollary, which says a quadrilateral is a square if and only if it is a rhombus and a rectangle. Or if it, you could say it if it has 4 congruent sides and 4 right angles, okay? So a square is going to follow all of those. So again, if you see something that's a rhombus and a rectangle, then it has to be a square. We can reverse that. All right, so let's look here. It says, for any rhombus RSTV, decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. So it's important to say we have a rhombus RSTV, right? So they drew one for us right here. RSTV, it's a rhombus. How do I know it's a rhombus? It has congruent sides. Okay, so the question is, will S be congruent to V then? Yes, no, sometimes, maybe. Well, a rhombus it is a parallelogram with 4 congruent sides, right? And if it's a parallelogram, we know that opposite angles are congruent, right? So won't S and V be congruent just because it's a parallelogram, right? So this is always going to be true, no matter what. Okay, what about RSTV? We already have that, right? For B, it says T is congruent to V. Okay, so T is congruent to V. So look at that. That's T and that's V over here. Are those 2 angles congruent? They sure don't look like it up on B, or up on the top one, but when I come down to this bottom one, this is still a rhombus. Is T congruent to V? Yeah, when it's a square it works, right? So if the rhombus is a square, then T is congruent to V. So T is congruent to V when it's a square, right? But are all rhombuses squares? No, not all rhombuses are also squares. So we can't say it's always going to be true because up here it definitely wasn't true, but down here it was. So we're just going to have to say sometimes true. Okay. Down here, classify this special quadrilateral and explain your reasoning. So give the most specific name. When I say classify, that's what it means. Give the most specific name. And it's important that we do that. We go to the most specific thing we can say. So on this case, I see 4 sides. That makes it a quadrilateral, right? But now we're going to say, can we get any more specific than those 4 sides right there? So I have 4 congruent sides. So as soon as I see 4 congruent sides, I know that that's a little more specific than where I was at, right? So 4 congruent sides, but one of the angles is not 90 degrees, right? So I can't be a square, but I could be a rhombus, right? So I would say the most specific name I can give right here is a rhombus. 4 sides is quadrilateral, but once those sides were equal, is a rhombus. Can I go as far as a square? Not really. So I have to stop at a rhombus. All right, for any square CDEF, I'm just going to draw it quick before I think anything more of it. CDEF, they said it's a square, so I know all of these are congruent. Is it always sometimes true that CD is congruent to DE? So CD is this one, DE is this side. Is that always, sometimes, or never true? Well, on a square, always, right? Because all sides are congruent. Now, if they change the shape, like a rectangle, that wouldn't be true. But on a square, that's fine. All right. For number 2, a quadrilateral has 4 congruent sides and 4 congruent angles. 4 congruent sides, 4 congruent angles. What's the classify it? What's the most specific name we can give? Well, rhombus is the 4 congruent sides. Rectangle is the 4 congruent angles. But now when you have both, it has to be a square. All right. So now let's find some more details here. And in some ways, I don't like that over here everything's shown up. So for right now, I'm just going to go like this, and I'll erase it in a little bit. Okay, I'll let you read it in a little bit. But right now, I don't want you to read that. Okay? Usually at class, I keep that hidden until I'm ready for you to see it. So we have some theorems here. If a parallelogram is a rhombus, if and only if its diagonals are perpendicular. So this is something new that we haven't seen before on the perpendicular. I can't spell. And I'm writing too big. Perpendicular. Okay. We did not see this on just the parallelogram, but it's true for a rhombus. So my diagonals inside there, AC and BD, are perpendicular. Okay, on a rhombus, they're perpendicular. So on my next one, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So now these diagonals are going to go through and cut the angle it goes through in half. So AC is going to bisect angle A, AC is going to bisect angle C, BD is going to bisect angle B, and BD is going to bisect angle D. So it's cutting that angle in half as that diagonal goes through. That was not true on a parallelogram, but it is true on every rhombus. And then finally, the last one on this list, a parallelogram is a rectangle if and only if its diagonals are congruent. So the diagonals in a rectangle are exactly the same length. So AC is the exact same length as BD. Every piece of those diagonals are the same length. Okay. Now, usually I would say, okay, now when I see all these, I see 2 new rules for rhombus, 1 new rule for rectangle. Why didn't they give me any new rules for a square? Well, this is where now I uncover all this and I say the reason is because a square shares all of these. So these properties are true for the square. So if a parallelogram is a square, its diagonals are perpendicular, just like the rhombus. If a parallelogram is a square, its diagonals bisect the pair of opposite angles, just like the rhombus. If the parallelogram is a square, its diagonals are congruent, just like the rectangle. So the rhombus had 2 new rules, the rectangle had 1 new rule, but really it makes the square have 3 new rules because it gets all 3 of them, okay? So if you haven't copied that, copy it. If you need to, pause the video and copy it, but make sure you realize that all of those properties go to a square. All right, so let's see. Sketch rhombus FGHJ and list everything you know about it. Well, they were nice to us, and they already sketched it, so I guess we don't need to sketch it. But let's say everything we know. Okay. By definition, you need to draw a figure with the following properties. The figure is a parallelogram. Wait, right? Is that what I want to do? Yeah. It's a parallelogram, and it has 4 congruent sides. That's what makes it a rhombus. Okay. The minute we see parallelogram, I'm going to tell you, and I'm going to remind you over and over, there's 5 things that have to be true. 5 things. One thing is opposite sides are congruent. There's 1. And opposite sides are parallel. There's 2. Opposite angles have to be congruent. There's 3. Consecutive angles have to be supplementary. That's 4. Diagonals bisect each other. That's 5. Okay? Do you remember I actually went through and said all those when we just gave the definitions at the beginning of these notes? Because the minute we see parallelogram, 5 rules. Okay? And we want to not forget those because those are going to be important. It says, by theorem, the diagonals of this rhombus will also be perpendicular, right? Oh, forgot what I was going to say there. Diagonals are going to be perpendicular. That's one of the new rules from the top of the page. And we also know the diagonals are going to bisect a pair of opposite angles, which is also from the top of this page, okay? So 5 things because it's a parallelogram, and 2 new things because it's a rhombus, okay? So keep those things in mind when you go to work with a rhombus. All right, last page. So you're building a frame for a painting, and the measurements of the frame are shown at right. So I have 20 on the top, 20 on the bottom, 16 on the left, 16 on the right. A says the frame must be a rectangle. Given the measurements in the diagram, can you assume that it is a rectangle? Okay, so one thing I notice is my opposite sides are definitely equal. Is that enough to prove a rectangle? No. The boards on the opposite sides are the same length, so they definitely form a parallelogram. I'm filling in for A here, okay? Because as soon as their opposite sides are congruent, I know it's a parallelogram. But I don't know if the angles are congruent. They didn't tell me enough. So I can't say for sure that's a rectangle. Now, for B, it says you go ahead and you measure the diagonals of the frame. So you measure this, and the diagonals are both about 25.6 inches. Now what can you say about the shape of the frame? Well, if the diagonals are congruent, I know diagonals of a rectangle are congruent. So if the diagonals of the frame are also congruent, then the frame has to form a rectangle, okay? Because now we used a new rule that's specific to the rectangles, so now that's enough to prove it's a rectangle. All right, we're going to sketch rectangle WXYZ, and we're going to list everything we know about it. Okay. There's my rectangle, WXYZ. What do we know about it? Well, it's, yeah, definitely 4 right angles, right? 4 right angles. Okay, because that's what makes it a rectangle. What else do we know about it? Opposite sides are congruent. Probably something we knew about it a long time ago, but it's also because it's a parallelogram, right? Opposite sides are parallel. Also because it's a parallelogram and everything is at 90 degrees, so it keeps them parallel. I know this is kind of funny we say it, but the opposite angles are congruent, right? Of course, all the angles are the same, but also their opposite angles are congruent. Also, the consecutive angles are supplementary. Okay. Diagonals. What do we know about the diagonals? If I draw this diagonal and I draw this diagonal, if I was a better artist, my diagonals are congruent, right? That's a new one that's specific to rectangles, okay? I have one more rule. They are congruent, and because it was a parallelogram before, I can come back down and I can say diagonals bisect each other. Okay? So, because it's a parallelogram, there's these 5 that are always true, just like it was with the rhombus. And because it's a rectangle, I have 2 more things that I can say about it, okay? All right, for number 4 yet, suppose the diagonals of the frame up in example 4 were not congruent. Could it be a rectangle? No, absolutely not, right? A rectangle's diagonals are always congruent. Never can they not be. So if we can't see it, then nope, no way. Okay, we've got to have that. All right. A lot of new rules here, and we need to practice them. So you have a worksheet. Make sure you pick up worksheet 8.4B. Okay, it's practice worksheet B. Should be the next one in your stack of worksheets. That's the one you want to work on. And I want you to do your best. Fill out what you can, try to figure out what you can. You might run into a couple problems where you're like, I don't know how I'm supposed to find this. That's okay. Do your best. Make an honest guess on it if that's the case. And we're going to look at them in class tomorrow and see what we should have picked up on them. Okay? Let me know if you have any questions.